I want to find the limit as x approaches infinity of x squared times a quantity 2 plus sine squared over x plus 10, or x plus 100. Okay, the first thing I need to do is consider sine. We know sine is between negative 1 and 1. Now what about sine squared? Well, let's look at a graph of sine. We know sine of x looks something like this. It's between 1 and negative 1. If I square everything, the thing in the red is still going to be positive. Greater than or equal to 0, in other words. But the green here, when we square the negative values, they're going to turn into positive. So they're going to be something like this. And when we do that, my range now is between 0 and 1. So sine squared is between 0 and 1. Okay, so that's the first piece here. The next one we need is to add 2. So I'm going to add 2 to everything. So 0 plus 2 will be 2, less than or equal to 2 plus sine squared, less than or equal to 3. Okay, and the last piece in the numerator will be the x squared. So I'm going to multiply everything by x squared to get 2x squared less than or equal to x squared times a quantity 2 plus sine squared and less than or equal to 3x squared. And the last thing in the denominator will be the x plus 100. So I'm going to divide everything by x plus 100. Okay. Now let's take a look at the bounds. So we'll look at the 2x squared over x plus 100. So we'll take the limit as x approaches infinity. I'm going to pull out the 2. So we'll have x squared over x plus 100, since that's the same thing as this piece. So if anything, we're just going to multiply by 3, whatever this limit is. So the way to do this is to find the highest degree of the bottom, which is x. So I'm going to multiply everything by 1 over x. So I'm left with 2 times the limit as x approaches infinity of x over 1 plus 100 over x. Now as x approaches infinity, 100 over x will go to 0. So I'm really left with x, and so the limit has to be infinity. So now I can multiply by 2. That still doesn't do anything. So what I found is in the green here, the x squared over x plus 100 is going to infinity, and so is this piece. So by the squeeze theorem, x squared times a quantity 2 plus sine squared is forced to go to infinity as well. So, in other words, the limit does not exist since it's going to infinity. Okay, let's look at another one. I want the limit as x approaches negative infinity of 5x squared minus sine 3x over x squared plus 10. I'm going to focus first on sine. So sine 3x we know is between negative 1 and 1. That's the first thing. The next is the negative. So if I multiply everything by negative 1, the inequality switches, and so I have negative sine 3x greater than or equal to -1. The next piece I need is to add a 5x squared. So that would be 5x squared plus 1 greater than or equal to 5x squared minus sine 3x greater than or equal to 5x squared minus 1. And the last piece we need is to divide by x squared plus 10. Okay. We have everything now, so let's find the limits of the two bounds. So let's first focus on 5x squared plus 1 over x squared plus 10. I'm going to divide everything by the highest degree of the bottom, which is the x squared. So that's, in other words, multiply by 1 over x squared. So I'm going to distribute this out. I get 5 plus 1 over x squared over 1 plus 10 over x squared. The 1 over x squared and the 10 over x squared are both going to go to 0. And I'm left with the limit to be 5. So this limit right here we said is 5. Now let's take a look at this limit on the right. The only difference in this function is instead of adding 1 over here, we're going to be subtracting 1. So really we're going to be subtracting 0, which really doesn't change anything, right? So it'll be 5 minus 0 over 1 plus 0. So the limit there should also be 5. So if we look now, so this should be negative infinity, by the way. And the good thing is it didn't matter since we got a nice constant. So if I approach negative infinity of 5x squared minus sine 3x, that's bounded by two functions whose limit goes to 5. So that means this has to go to 5 as well by the squeeze theorem. Okay. Let's look at a more intense limit. So we have a limit as x approaches negative infinity of x squared times sine x plus cosine squared, or sorry, cosine cubed x over x squared plus 1 times x minus 3. Okay, so this one looks very intimidating, and really the question is, where do you start? So you probably guessed it, we should start with sine. That's the easiest one. So sine, we know, is between -1 and 1. The next piece we need is cosine cubed. Well, we know cosine is also between -1 and 1. And here I can just cube all the sides. The reason we didn't, in the previous problems, the reason we didn't square them is because the negatives became positives. But here, if you're cubing a negative, you're still going to be cubed. So we can still cube it. So we're going to raise it to the third power. So just be careful when you're doing things to the fourth power, or to an even power. So we have -1 less than or equal to cosine cubed less than or equal to 1. So now I have sine. So I have a bound for sine, and I have a bound for cosine cubed. So in this problem, I need to add them. So sine x plus cosine cubed will be between let's see, the lower bounds is -1 and -1, so that's -2. And the upper bound is 1 and 1, so that would be 2. So just to be clear, I'm adding -1, -1 for the lower, and 1 and 1 for the upper. So now I have everything in that parentheses, so I just need to multiply it by x squared. So I have -2x squared less than or equal to x squared times the quantity sine of x plus cosine cubed less than or equal to 2x squared. Okay. So next we need the two pieces here. Well, let's see. So this one's a little tricky. I want to divide first by x minus 3. So let's divide by x minus 3. And here, since I'm dividing by x minus 3, I'm really dividing by a negative number since we're looking at x to be negative infinity. So x is a negative number, minus 3 is also negative. So the inequality is going to change since we're dividing by a negative number. Okay, and the last piece we need is the x squared plus 1. So I'm just going to put it on here. X squared plus 1 is going to be positive, so we don't have to worry about dividing by a negative. Okay. So now we will be taking the limit as x approaches negative infinity. Notice the 2x squared over x minus 3 times x squared plus 1 is the same. So the two bounds are the same. The only difference is the negative. So let's ignore that for a second. Let's ignore the negative and let's just focus on finding the limit of just the 2x squared over x minus 3 times x squared plus 1. Here it's probably better to FOIL it out. So we'll FOIL out the denominator. We'll get x cubed, let's see, minus 3x squared plus x minus 3. Now I'm going to find the highest degree of the denominator, which will be the x cubed. So let's multiply everything by 1 over x cubed. I have limit as x approaches negative infinity of 2 over x. And then we have 1 minus 3 over x plus 1 over x squared minus 3 over x cubed. And as x approaches in negative infinity, the 2 over x, 3 over x, 1 over x squared, and 3 over x cubed, these will all go to 0. So you're left with 0 over 1, which is 0. So this one will go to 0. And the negative doesn't matter. Since we said the limit is going to 0, if I multiply by a -1, it's still going to 0. So I don't really care. And now x squared times sine x plus cosine cubed over x minus 3 times x squared plus 1 is bounded by two functions whose limit goes to 0. So by the squeeze theorem, the limit also has to go to 0. So this limit also goes to 0.